Hey guys, so today we're going to start talking about this idea of conservation of mass. And our question is, how do chemical reactions affect the mass of the substances involved in it? So there's two different things when we talk about reactions. There's reactants and there's products. So the reactants are the matter that you start with in a reaction, and the products are the matter that you end with after a reaction. And this can be the same or different depending on the reaction or the type of reaction. Both reactants and products can be described by their physical and their chemical properties. So just like anything else we've talked about, there are physical and chemical properties to each. So when we talk about this idea of conservation of mass, essentially what we're saying is that the mass of the reactants is equal to the mass of the products. And we're talking about the total mass of all the reactants and the total mass of all of the products. Mass is never destroyed, but it can change. So it can change from a solid to a liquid to a gas into another type of matter, but it is never actually destroyed. So there's a couple steps when we talk about how to actually write this chemical reaction. And the first one is to write down the reactants on the left and the products on the right. The next is to fill in the known masses, which we can get from our periodic table. And then you need to make sure that your before equals your after in order to determine any unknown masses. And then you check your answer by plugging in all of your numbers. So when you look at it, a lot of times you have these things called coefficients in the front. And these are these numbers, like you see this 2 in front of this H2. Well, this tells me that I have 2 hydrogen molecules. But in this case, we have H2. So we have 2 H2s, which means that if I have 2 hydrogen molecules bonded together, because of this little number down here, it tells me that they're together. And then I have a 2 in front of it, it means I have 2 things of 2 hydrogen molecules. So I have 4 molecules total, but they're each bonded to another one. And the same here, it tells me I have 2 water molecules, H2O. So our reactants are on our left and our products are on the right. So when you have a coefficient and there's multiple elements after it, you need to actually distribute that coefficient through. So first you'll multiply that 2 by the Fe. So now you have 4 of those total because you already had 2. Now you have 4. Then you multiply that 2 by the O3, which gives you 6 because you had 3 oxygen molecules bonded together and 2 of those, which gives you a total of 6 oxygen. So if you were to look at this in full after distributing through, you can say, here are my products, or here are my reactants, here are my products. What do I have of each one? So if I look at this, on this side, on the reactant side, I had 4 of the iron, which gives, and on the other side, I now have 4 of it again on this side. So you'll notice that we have the reactants, the products, your iron on one side matches your iron on the other. Now, if you do this distribution, we said we had 6 oxygen. If we go to the other side, we notice we now have 3 as a coefficient and an O2, which means 6 oxygen on the product side. And again, we had 3 carbon. And if you distribute that through on the other side, we have 3 carbon again. So you need to actually balance these equations out based on what those coefficients were. Once you guys have completed this, you're going to move on to your packet for today, where you're going to actually be practicing balancing equations based on how many of each of those things are on each side. So it's going to take a little bit of thinking. You may want to list out the products and reactants on each side so that it's in this form so that you have each element listed separately. Once you're done with that, you may move on to your exit ticket for today.